Okay, for people joining this live stream, we are talking about incremental development in Wolfram Language. We have a variety of topics today. Okay, first up, names and design of the curry operator reversed function.
So here we have your last suggestion, and then there is some code that if you evaluate, then we can play the examples. This code uses curry operator reversed. So So our current idea is to make curry to have this structure of first having the number of arguments and then the function in a separate pair of brackets. And then operator would do what curry was doing before, and we have reversed, which is a separate function.
So curry is curried.
Well, we will yes. Yeah. There is the question of whether we want to support still the old syntax of still supporting.
We could, but I mean, in this case, if we're using reversed past participle, this should be curried.
Yeah.
So that would end up being okay. What would we call it if it wasn't? So, I mean, this is turning F. I mean, we obviously have the term subvalue in our language, although it's not perhaps our finest term, but people understand what it means.
Yep.
All right. So operator
seems, I mean, it's very nice. It reads very well, but it has, I mean, we were worried about the generality of this name.
Have we asked other people about it?
I have not.
My only concern is that whether we actually will need that in the future at some point when we actually have nice operator algebra or so on, differential operator stuff like that, whether we need that term, but I'm not sure.
I think differential operator is a fine thing for a differential operator.
No, but the general algebra, operator algebra, like coordinate-free operators.
Well, Jose would be a
equation.
What's that?
For example, how would you express the Schrödinger equation currently?
Well, I mean, you might use this operator thing here. I mean, because right now we have, for the, okay, so let's look at how these play together. Okay, so right now we have del. So I could say del x squared plus y squared xy. Whoops, what is that doing? How does del work?
I think you mean grad or diff.
Oh, yeah, I do mean that.
Well, in this case, probably grad, the gradient of a scalar.
Okay, yes. My thinking machine isn't properly. Okay, so now we would do operator. So what we do, if we did this, operator grad xy, if I'm not mistaken, that would just work. Why didn't that work? Why doesn't that just work?
Operator takes the number of arguments.
Right, so it would be grad comma, yes, xy needs to be in a separate pair of brackets.
Because it's curried. Okay, all right. So you're saying operator grad of that. Right.
Yes, that makes sense.
Right. I mean, the only question would be, if we're doing operator algebra stuff, would we in fact want to would we want this XY, which of course you don't usually ever mention in the operator algebra stuff. It's just sort of implicitly assumed, if I'm not mistaken. Would we want that somehow in the first argument?
The truth is that I don't see a way of having a super general operator algebra that fits the needs of everything. I mean, if we are in quantum mechanics, we will have something which I don't know yet what it is, but something that is adapted to that.
Right.
I mean, really the problem comes from the fact that all of this should be expressed in terms of functions. So we shouldn't talk about an expression with x and then have to give the variable x. We should have the grad of function of x, y, comma, x squared plus y squared, something like that.
What do you mean?
Well, here, I mean, especially in this form, you are committing yourself to the variable names x and y inside the operator form. But really an operator should be applied to a function and not an expression. So
I understand that. Okay, I see what you're saying. This should be a lambda effectively here.
Yes. I mean, grad itself should, like derivative, right?
You know, this is such a can of worms.
It is.
Because you know, the slottiness of coordinate systems is very weird, right? Like r and theta, do those correspond to, you know, the concept of those as slots is really strange. I mean, tensors, okay, this is where we get into the same can of worms as coordinate systems, and I think it's just a big notational can of worms. Because like a tensor, the slots of a tensor cannot be, I guess, okay, can they meaningfully be r theta slots?
You have to name it. You have to tell somewhere that you are using the polar coordinates.
Yeah. But normally in normal tensor notation, if I say t mu nu,
yeah,
those coordinates, I mean, there's a coordinate system, and it can be in, you know, one of many coordinate systems that those slots exist. Although, am I being very confused?
No, you are right. Every time that you do tensor calculus, you have to specify in which coordinate system you are working. And what people typically assume is that they have one and they have expressed everything in that one, and they just don't mention it at every step.
Right. Right. But that's a little different than saying everything is a function, I think.
I think this is a bit like I have a sphere and then I represent it in this way or that way. Once you have decided how to represent the tensor in some coordinate system, then you have functions or arrays of functions.
Yeah. Well, arrays of functions are another can of worms because the index there, what index is that? Right. If it's a 4 vector,
mm-hmm.
and the 1, 2, 3, 4 of the 4 vector. Anyway, I don't think that's okay. Let's come back to this. I mean, what is the minimal case? Go ahead.
My point is that I don't think operator is going to help in any way doing tensor calculus or anything else. And because we already talk in many places about operator forms, somehow we have already used up the name operator, I think.
Yeah, I agree. But I don't understand why we want this rather than operator. I see, because we can't do this. We have to have it be curried all the way.
Right. We need an argument to specify the number of arguments, or if we want a permutation because we are carrying the second.
Right. Somebody's asking on the live stream, what does curried mean? It means we're just saying, so in this case, we're saying curry of 3 f x y. That will do nothing. I see. What is the count there? So the count is the first element there is the actual function itself.
Right. That's a comment I've written there somewhere, that in this new notation, one has this feeling that one is missing.
Yeah, I understand. This is like 3 is, I mean, the alternative would be a curry f comma 3 of XYZ.
That's the design we had before.
Yeah, and what's wrong with that?
There's nothing wrong, but if we have curry of f comma n, then we should have an operator form of curry, and that would be curry of n applied to
I know,
f.
which is fine. I think that's fine.
I mean, I'm perfectly fine with these two. I mean, there may be some people have made some reservations about the default for the second argument. I think the current default is confusing, and if we separate the function into operator and curry, then it becomes a lot nicer.
Okay, fine. So then what is the operator form of operator? The operator form of operator, like the operator form of curry, is... Okay, sorry. You've got a different thing for the operator form of operator.
Sorry. If we do admit both curry f bracket, 3 bracket f bracket, and simultaneously f comma 3, then curry and operator are absolutely identical, except for the fact that operator has a default for the second argument, while curry is carryable. That's the only thing. So if we write operator, so it's the interpretation of the one argument case.
Okay, so what's the one argument case? So operator of f.
Yes, that's equivalent to operator of f comma to 1. It's meaning it's waiting for 2 arguments and it's going to reverse them, which is what we always do, or in most cases we do with operator forms. So try now XY.
Okay, although in most of our operator forms, I mean, if I say something like, sort by, length, and then I do, whatever I do here, I'll sort by, even Q or something.
Yep.
And I do this, right?
Exactly.
Then
so that's equivalent to sort by list comma even Q. So you see we are reversing them.
No, I understand that. But what's different is the head is here, right?
Mm-hmm. Right.
Yes,
so
I think the point is that the way to use the operator form is to say my op equals operator of fx, and that thing is then applied to y. So you would almost never write it the way it is here.
But so this would be operator sort by even Q, and then this, right?
Correct.
I just think it's weird that it has to curry this piece in. And the only reason it has to do that is so that operator...
I mean, if you require that argument, then you could not curry. I mean, at the moment we can say operator of f. We can use operator of f of x and operator of f of x and y. And that's why I think for these cases, the curried form is the more useful one.
So you're saying we've got that, and we apply it to x, and it does that.
That's how our operators work, right? I mean, every one of our operator that reverses arguments could be constructed in this form. It's operator of sort by, comma, even Q.
Yeah, but it isn't. Okay, I see. So you're saying operator of sort by is the thing that is turning it into an operator form.
Yes.
Then you're giving its arguments.
Mm-hmm.
Okay, well, let's look at reversed then. Where's the reversed?
Oh, I don't think I have examples there, but it's very simple. Just reversed of f, x, y. And now reversed takes all arguments in one go, exactly.
I mean, that's a different kind of animal. That's useful by itself. but it
notice that. Okay, but how does it play with all these others? So,
well, you can put an operator inside reversed.
sure. Okay. Reversed behaves as a function that has its arguments reversed, right?
Yep.
And presumably you can say that you only want to reverse 2 of the arguments, correct? So if I say comma z here, and then if I say comma 2 there.
I haven't done that, but we could do that.
We should do that because we don't want options reversed, for example.
Mm-hmm. Yeah, that's a good point. Yes.
I mean, there's even an argument that the automatic form of reverse, that's a stupid idea. No, we should just give the number of elements to reverse in a take spec, basically.
Yes, I think so.
Okay, let's come back to the operator thing. We got 3 names here that are all a little bit different in character, which I don't like very much. We've got curry, which is a totally obscure name. I mean, it's an inside joke, not joke, but an inside thing, basically. We've got operator, which is a nice, understandable name, except that it seems more general than. See, what bothers me is the way that we're having to do, this currying in of things. Okay, the difference between operator and curry.
Right now, it's just the interpretation of the one argument case. For curry, it's an operator form
Of curry itself.
Yeah, and for operator, there is a default second argument. So in a sense, the one argument case of operator is truly a 2 argument case.
Okay, what if, to make a somewhat radical proposal, what if we added the word function here? So we said, does that help us?
Well, in carried function, the first argument is not going to be a function, which reads a bit strange.
I mean, reversed function makes a lot of sense because we already have reverse in various ways. But for curry and operator form, I don't think it's necessary.
And if we use form, even though it's overlapping with something else, carried form and operator form.
Forms are for typesetting, yes.
It has its own problem because we have many other forms.
Yeah, I don't like that very much. An operator doesn't really have a past participle. Operated.
But we always say operator form.
I know. And we could call it operator and have that be. See, the thing is, this operator thing is doing something particular and special, which is it's flipping the argument order.
In the default case.
And again, you're against having it go operator of f comma y applied to x.
Well, the problem is where do we put all the information in the second argument of operator?
What information is it that we need?
imagine these cases in which we have to carry two arguments, like map@.
I don't even know what operator does in that case.
So the operator form carries two arguments. So it may be good to look at our current page for carry to see all the power that there is in the second argument. Yeah, so there, for example, how do we imitate that case with carry? Or sorry, with
this case of map@.
Yes, exactly. So our original idea was to have something called carry in version 12 that can simulate all possible operator forms. And
yeah,
yeah.
No, I understand. And I know that carry can do that.
Exactly. Carry can do many things.
Do we have a page for carry here?
It's in the system. I mean,
I bet only in 12.1. Oh no, it's right here. Is that right?
Exactly. That's what I mean. So what is being proposed here is to rename carry to operator and having the exact same syntax. And then we do something different, slightly different with carry itself.
Mainly that it has a curried form.
Exactly.
Yes, I mean, my main concern about what we're seeing here is that the one argument from carry of f, everybody would expect that to be the carried form of f, and it is not.
Sorry, say that again, Roman.
Well, this carry of f, the second usage line, everybody would expect that to be a carried form of f. But it is something that also flips around arguments and does funny things. And so that is my main reservation against the default second argument. And then if we start with the first usage line carry of f comma n, then carry of all things should have an operator form. And so we end up with the current proposal of having carry of n of f as the natural operator form of carry. And so
yes. All right. So the thing that is a bit bizarre is the two argumentism of operator. That we're, the default is this, but if I were to go, for example, like this, it would do something totally random, right? Why should operator be so two argumenty?
Again, because in the default case, we try to imitate what we do in the vast majority of cases.
Okay, is there some way to reflect that in the name? I mean, I'm not suggesting, that's not a good name, but
well, should the function be named after the general case or after a special case with default argument?
I think it should be named after the special case, probably, because. But let's see. Are you proposing that there's be a second argument here that specifies the curry spec, basically here?
Well, that's the design. I mean, the second argument specifies exactly how many arguments you want to twist in which way. That's what carry does now, the third and fourth use case. But the default second argument of operator is 1,2, which is the same default as the current
2,1.
2,1, sorry, yes, which is the same default as the current carry function.
I know.
And this
right.
is
my concern with
it's the most useful default.
I agree with you, but my concern is the word operator sounds more general than something that does a 2-1 flip.
Yes. Is there a standard term for that 2-1? I mean, there are combinators that have this behavior like this B, C, W, but They are not very widely known, so I'm not sure we should name it after one of those.
Do you realize that combinators are 100 years old next year?
Yes. Oh, yes.
1920.
So we should have them in whatever version we will bring out next
we
year.
Absolutely should have combinator K, combinator S. I mean,
yes,
I think we have.
I agree, and I have lots of ideas about those. And
oh, you do? Well,
I
please
mean,
express them because
we need a binary operator. We need some nice syntax, right? We don't want to have nested square brackets, so we need a left associative binary operator.
yeah, didn't that get specified? I mean, don't we? I mean, the left associative.
We have left associative binary operators, but none of the symbols there is one that you want to use for combinatory application. I mean, we decided to have that discussion at some other point, not to overload this meeting, but
well, but it's basically left. What is it called? I mean, it's because
there's left T and there's a left triangle operator, and there are all kinds of.
No, I don't care what the operator. I mean, the operator could be some kind of circle thing with some weighting on one side. That's fine. I mean, I would say that a circle with some kind of slightly filled on one side would be a reasonable way to express this, which is kind of a compromise, I think. But the issue is, what is the thing called? So we have.
Well, the standard name is combinatory application. It is a form of application, but it's not. I mean, it's not the same that we use for we use apply an application for.
But we don't have a name for this. It just does what it does, right? Yes, just because we don't have a name for for this thing.
Because I mean, because it's a constructor of the language and it's not an operator. I mean, this one is, but this one is composition, but composition is kind of the other way around from application. But the @ sign itself is not an operator. It's a special form.
Right, but why is this thing an operator? Why is the
well? This is just the infix form of ordinary function.
No, I know, but this combinatory application. Why isn't there just an infix form of combinatory application?
Because it associates the other way around.
I understand that, but assume that we could have a form. Yes, assume that it was something like So assume we
should find a symbol. I mean, now that we have Unicode, we shouldn't really.
Yeah, I agree that the fact that we haven't needed it in how many years, 30 years, suggests that we should have it work with Unicode, and hopefully.
I mean, something like that is fine, but the default should be a nice graphical thing, right? Like you said. Circle.
Right, but so all we have to do then is define, like we have the @ sign. It doesn't represent. There's no function in the language that corresponds to @ sign. It is just a syntactic form.
Yeah, but here that's not what we want. We want it to be a proper operator that passes into a left associative combinatory application without any meaning. Because most of these combinator expressions have infinite evaluation chains, so we have to be very careful about evaluation.
So this is just purely typesetting, right? It will not do anything.
How would you make it do something? You said a combinator evaluate or something.
Yeah, you would have to have some very controlled application, because I mean the evaluation order matters, whether it's leftmost, innermost, or parallel, and in most cases, you don't want to evaluate it. Think of the fixed point combinator, so that will just explode if you try to do anything. So you want to use it only for certain transformations.
And the end of this chain is not an actual argument. It's just another combinator, right?
Yes. Combinators do not have variables, right?
Right.
Well, there are constants here, so you can have other terms, but
you don't usually use them. I mean, like church numerals don't use constants; they just use other combinators.
Yes. I mean, well, they start with K or S as a kind of constant in an inert position.
I understand, but it's still just a combinator.
Yes.
Is it clear that here we need a nested expression and not some sort of string that can be manipulated faster?
Oh, I think what we want to do, absolutely, when we do this, we will have something that says, combinator, and then you can type SK, whatever it is, right? How do
Yes.
but you have to put brackets in somewhere here.
Well, I mean, no parentheses. You use parentheses for grouping, and the
So like
yes.
with regular expressions, we should have something which is essentially and I think we've got code for this. I mean, there's a person who worked with Todd for a while doing these.
Yeah, I mean, that's straightforward. I mean, you would turn this into a nested form with the combinatory application binary operation.
It's not okay, but this thing. So if I didn't have those parens, I would just.
It would nest to the left, right?
But why is it nesting at all? I see. It's not an n-ary operator because
it's a binary. It's very much a binary operator.
So you're saying that there's a binary operator which says combinator apply or something, which is just a binary left associative, which has a form that is left associative. That will. Why don't we just implement this, Roman? I mean, we can do this. Let's call it. I mean, I don't know whether we want to say apply.
We should find a nice symbol, and
I know.
I mean, we already have left associative binary operators without meaning, so we can just duplicate that code.
But sorry, I'm still confused. Is it clear that expanding that string into a very nested thing is more efficient? I mean, the result is going to be less efficient to manipulate, right?
I think it's just efficient to type, because in combinators you don't want to type anything. It's just like the multiplication sign in calculus, which you don't want to waste time typing. And since we need something, if you write it out in proper syntax, then something like combinator or combinator expander so is very nice just for input.
Right, and that way we would be able to say, if we just had a thing called combinator, we'd be able to say something like this, and that would be by default the K combinator.
Yes, so that's a possibility if we don't want to name them, right? But we might want to name them.
Well, we could, yes. I mean, we could call it.
We should have.
Yeah, but look, combinator K could typeset. It could really go all the way back, and it could be this, Gothic, whatever it is.
Yes, why not? I mean.
Yeah, but then combinator K can just typeset that way, just like this thing can typeset in a certain way, and it may or may not. I mean, the question of whether this auto expands is a different question.
I mean,
it could be that doesn't auto expand, and it just.
The slight question is because you cannot just put any letter there, right?
So it gives an error.
Yes, but
I mean, if you do Roman numerals and you put a J in there, it's going to give an error.
Yes.
I mean, we are, and I don't know, didn't Raymond Smullyan have every letter of the alphabet in his bird calls? I don't know. I mean, certainly things like, I mean, they're conventional. The Y combinator, there's a J combinator, as I recall, that's fairly well known. The I combinator, obviously. We should implement this. We should have this certainly before. I mean, which kind of means we have to hustle because we need it before. I was trying to find when Schoenfinkel originally published his paper, and I don't think I succeeded in finding that out. I only know it was 1920. Schoenfinkel did not have a happy time after that, unfortunately. The basic principle of people who worked on combinators is they either go completely bonkers or they lead the most minimalist lives you can imagine. At least that's my generalization about combinators. Might be wrong, but I have a few examples of that at least. Okay. No, we really should do this though. Really should do this. Let me save this someplace. Anybody, Devin, do you know where I should save this stuff? We have
I couldn't think of anywhere else besides miscellaneous, but that being said, it might be a good idea to have our own ILD folder or like a functional programming folder.
Yes, okay. Well, let's do something for functional programming. I agree. And I'll just put this in SW notes. Okay. All right. So Roman, do you think you could okay, so I'm proposing that the operator be a circle with a little I mean, it'd be nice if it's a Unicode character, I guess. Do we think it should be Unicode? No, I think it should be our own custom Unicode, because otherwise it's going to get messed up.
Yes, I mean, I can certainly, I mean, Itai might also have some interest in this, because I've had previous discussions with him and Jose probably. So it's something we can just discuss among ourselves, and then as soon as we have a sensible thing, we can come back here.
What I would propose is that, I mean, small circle on its own, I think is a meaningless binary operator, as I recall. Is that what we did? Yes. Is it binary? I don't even know if it's binary. It seems to be n-array.
Is it even an operator? No.
Oh, why are you saying no? I think it is an operator.
Oh.
Yeah,
okay.
There it is.
Yeah, okay, yes.
It's an n-array operator.
So we have something like left T or left triangle, which already is left associative. So we just work with design to, or with Eric, about whether perhaps there's something in the history of mathematics that is a suitable symbol for that.
Well, that seems to be n-array again.
Okay, there is one that is binary. Let me see which.
Okay, but is this the right way round for a? If that was the symbolism here,
I think it should auto-convert into two, nested two, properly bracketed, like power does, for example.
What are you saying?
Try power XYZ. So now if you do input form,
do what?
Input form or full form. You see it introduces another one. Now, I'm not sure whether it's on the right side, on the correct side.
No, this is left associate. It should left associate. So it will, yeah, I agree. It should do that. But it should print, right? Like every left associative operator. I mean, like rule is an associative operator, right? Rule has an association there that is right associative again, like that. But it still prints like this, which is what this should do. Make sense? So does this mean anything, Roman, or is this a pure combinatory combination thing? In other words, if I apply it to something as a sub-value type thing, does it evaluate or not?
I mean, that's really a tricky question, because certainly certain forms can be evaluated, like SXYZ or KXY, which, but in general, you don't want to just blindly start evaluating.
Look, I would propose the following. I would propose that this thing, like our composition up here, okay, composition just sits there without doing anything until it's applied to something, right? So similarly, when it's a pure combinator expression, it just sits there. And we'll have all kinds of operations that act on the combinator expression. But then if you apply it, I don't see why it shouldn't just go ahead and compute in this particular case. So if this was applied to something,
well,
what I would
there's
expect...
no notion of applying, because it's already an application. And there are certain easy cases, like if you have KXY or SXYZ, that would apply. But even that, if you do that on the outside, then you might still lead into infinite evaluation chains. So we might need some functions to control the amount of evaluation.
No, I understand that. When you have a classic combinator, I completely understand that. I mean, but I'm talking about if you have just a random function from the system in there, you could perfectly well do that, right? I mean, because you could. The issue with the combinators is, I mean, I just had them actually in some recent blog post of mine, but I also have them in, in general, just to let's see, I had some nice combinators as I recall. Yeah, I mean, these are general. So this, in this case, what I did here was I did S of, yeah, so in this case, what I was doing was S of S of S of, so I was doing the application explicitly like that.
Yes.
Does that make sense?
I mean, we should obviously have a way to transform those combinatorial applications into the square bracket notation, but this becomes unreadable. So we really need that binary operators.
Well, okay, let's look at a sample here. Okay, I agree that that's not in the that is questionable in terms of readability. I don't know whether it would really help very much to just say S of S of S of K of K of S of S of whatever it is, right?
Yeah, I mean, there are usually much fewer parentheses.
Well, because you're representing it using
because it's implicitly left associative, right? Yes.
So in this case, I wonder if I can get this right, and the problem is these rules, when infinitely applied, often loop.
Yes.
Okay, so there's a typical example. So what you're saying is that's a huge mess, which I completely agree with. Look at that creature. Okay, so you say if we were to represent that with a binary operator, I mean, if I looked at this thing and I say, what's the tree form of this thing? Oh, for goodness sake. Oh, because it's all in the head. Right? It's all the most of the action here is in the head. How do I even do this? What we should probably have a tree form that goes into the head. But your point is that what we need is something which goes from, I mean, I would claim that as soon as you apply to anything, it's going to have to turn it into brackets, because otherwise, okay, let's have a separate meeting about combinators.
Yes.
But it would be nice to actually nail that down. Okay, let's come back. We're back from the land of combinators. Okay, so right now, okay, we're back to this operator thing. Okay. Okay, the problem is we don't want to use up the word operator for this fairly specific thing. I mean, something based on the word operator would be really nice. And that's a stupid word. These are all silly words. Operatorized. Now we'll end up with operationalized.
I mean,
you said we're trying. Yeah, go ahead.
What's the general consensus about using form in this? I mean, mostly it's used for input-output, but we already have some forms which are not like Horner form.
I can't even imagine. What is long form?
Oh.
That's crazy.
But I mean, we almost exclusively use form for typesetting.
Yes. And I could imagine, like even for our combinators, we might want something that's called operator form of the combinators as a, okay, what would it look like if we said operator form? It doesn't really help anything because it's like reversed. Okay, is there any other way we can decorate the word operator? What does it really do? Explain what it does. It makes an operator form in which this argument
carries the function, but it swaps the arguments. So that's kind
yeah,
of
okay, but that's in the category of, I mean, okay, what about swapped? That doesn't really help because it's got currying as well.
And that seems to be the name for reversed, not for operator.
That's pretty weird.
I mean, curry, something with curry.
Roman, you've lived with curry for way too long. Most people in the world think it's an Indian,
okay,
dish.
Yes.
Yeah. I wonder if we search on the web how far we have to get. I'm just curious. If I did a web search for the word curry, I wonder how far I have to go. I wonder whether you can even tell which one it is. Oh, come on. What's it doing here? Well, okay, fair enough. There's people there. Okay, we didn't have a single, not a single one of these is the curry in our sense. Old Haskell. Did you know that Curry College was founded by an ancestor of Haskell Curry? There's a piece of trivia for you. Okay, as operator, that's an interesting thing suggested by Lucas on our live stream.
Is there any abbreviation?
For what?
Operator? In the same way that we have grad and things like that?
Op. Yeah, I don't think as operator helps. Why does that help? I mean, look, the issue is not that it's being turned into an operator. That is a perfectly reasonable piece of communication. The issue is that it's this weird two-argument form, which doesn't feel very general.
Yes, I mean, we call them operator forms throughout, I think.
But for that particular, yeah, but is it for that particular case only? Or do we have other operator forms that are like four-argument functions that degenerate to something smaller?
Mapat?
Yeah, we have a few. Mapat and take largest by, things like that.
Okay, so let's look at the operator form of take largest by. Okay, so it is a two-argument. Okay, so you guys are saying that, yeah, we have no idea where to put. I mean, we could have an operator version, an operator thing here, where we just start accumulating arguments, y, z, w, whatever. Oh no, we have to give the main function here. It's very unsymmetrical, right? I mean, we give the main function. If the second argument of the operator thing, okay, there's an uncurried version of this, which would look like this, where that goes applied to w, for example, goes to f of w x z.
Yeah, but how do you know where to put it?
Well, that would be the convention of I know. There's no way to do that. Well, except that all of our actual operator forms work that way.
Well, I can imagine, no, Mapat, think of Mapat, which is the second one that's going to be
Oh, for goodness sake. Yes, you're right.
And we might want operator forms of, I don't know, partition, in which we want something special of the first, third, and fifth argument.
Okay, so is it the case that with the curry spec, that this thing here can have multiple arguments in it, right? That single bracket thing can have multiple arguments in it. True?
Yes.
Okay, so there's a curry spec that allows that. So how would you write map_at as a curry spec or an operator spec?
Yeah, so that would be operator of map_at, and then the second argument would be 1, 3, 2, and then you can place there f, comma, pos, or pos. I mean, it doesn't matter whether you put them in the same argument or separate, and then the list.
So the curry spec doesn't care whether the things are combined like that?
Yes, so we can have arguments in the same pair of brackets or separate.
And should we have a way of forcing the curry spec, of forcing that to work or not work?
What do you mean? I don't understand that.
Well, I mean, we could require that these be curried, right? And consider it an error if they're not curried.
Well, implementation-wise, it's all based in accumulating separate pairs of brackets into a single one.
Okay.
Because otherwise we need towers of definitions. Remember that we don't have a pattern for an arbitrary number of pairs of brackets. So this is both a feature and a need for the implementation.
Okay. Okay. Well, all right, let's try going with this operator thing. Let's put it in the system. Let's see if people freak out.
I mean, it's still experimental, so maybe someday someone will think of an excellent name for it. But I like
people are going to start using this. I mean, people are going to start using it. So, by the way,
yes,
Lucas
but I mean
on
the
our live
same is true
stream
with the
has asked
current curry. So as long as it's experimental, we have to.
Well,
be able
we're
to
not
make
going to
changes.
be doing that. Yeah. So people, are we going to break a lot of code with the existing? I mean, Lucas was suggesting this is not going to work because of the holding issues with f of x and so on. If this was a function, you kind of don't even need this. By the time you've defined a function, you might as well not have any of this whole structure. By the time you're prepared to define a function here, you can just say, map_at hash, f hash pos, and then you're done. So, okay, so the one thing that's going to fail is the one argument form of curry, if people have used that, isn't going to work anymore, right?
Right, it will have to be renamed operator.
Yes, well, that's life. We need to go back and fix various things in the 12.0 description, 12.0 marketing pages and things like that would have to be fixed. All right, let's go ahead and implement this in 12.1 and let's see what people think about it. Okay, I would really not like to not have to change it again, but I think we've and then Roman, you're gonna look at this combinator thing.
Mm-hmm. Yes.
And okay, finally made it through that first section. Paired. I think this is not a particularly sensible idea. What do you think?
I was trying to relate it to other things like association map, fold pair, etc.
So my idea was, you get what I'm suggesting here.
Yes. So something I added there, this geodesy data example. I think something we do frequently is this idea of I have a bunch of objects and I want the pairs of the object and the value of a function. An association map does almost that, but then, for example, it doesn't play well with column form, matrix form. So I have the impression that we still do this mapping.
Yeah, I mean, the very common thing that I end up doing is, I mean, clearly it's not super difficult to say hash comma f of hash.
Mm-hmm.
And there's a certain argument that that idiom, I think that idiom is probably okay. I think that idiom is as clear as anything. I'm not sure this really helps. What do you think? I mean,
one case where this is needed is if you want to tabulate function values, then this is a very useful and slightly cumbersome way to generate a table of values.
yes. I mean, like for example, if we say, I mean, if we define these paired things here, you know, if we were to say array of prime comma 10, right? But if we were to say array of paired prime 10, that's kind of nice. I mean, it's, you know, it's seriously functional programming oriented, but it's kind of nice.
But you see how this is almost association map of prime range 10.
What is it?
So association map of prime comma range 10.
Yeah, I understand.
For example, if column did something nice with that, I think we would use it a lot more.
Column or column form?
I think we call it column now. Or perhaps I'm confused. But I mean, if you apply column to your 335, it's easier to read.
Yeah, I understand. Well, that's just a trivial thing for us to fix.
Or even greater table, yes.
Right.
I mean, you could turn it into a data set, but
Yeah, right. I mean, if we said data set of 336, that looks quite beautiful. I agree that I think column should format something more like this, probably, or something. Yeah, I see no reason why column shouldn't format that association.
column or grid? I mean, column gives single columns.
Well, I understand, but grid of %335. Oh, I see what you're saying. I see what you're saying. Yeah, I mean, that obviously works. But
yes.
Yeah, but that we know that works. I mean, the issue is, by the way, Sandra on our live stream is pointing out that, of course, association map has the issue that, I mean, it doesn't deal with repeated keys. So it's really very different from paired in that sense.
Yeah, good point. Yes. Still, I think column should do, I mean, grid is for two-dimensional objects and association is still one-dimensional. So column could give what grid is giving, but should be.
Well, I don't think it should quite give that. I think it should give something which is a little bit more like it needs to give some definite print form. There's no harm in it giving some definite print form, and we should just make that work. And Chris Carlson would probably be the right person to look at that, because he's working on the data set formatting stuff. So why don't you feed that to him?
I'm here, sorry, but I was listening with one ear.
We were talking about formatting for column and formatting of an association in column.
Yeah.
We wanted to do something better than nothing. Right now it's doing nothing. If you feed it to a data set, it does something quite beautiful here.
Yeah.
Right. So the idea is to have column have some print form there.
Okay.
And we're leaving it to you to figure out what that print form is for now. All right, look, I think paired isn't totally stupid, and I think we perhaps should introduce it. Worst case is that, boy, you've got a bunch of uses of it here.
Yeah, I was trying to relate it to something else. For example, an operator form of nest list. We don't have operator forms for that. Probably we should.
Nest list. What would its operator form be? I mean, the reason we don't have an operator form of nest list is because, oh, I see, it doesn't even elide, does it? It doesn't have any elision.
It could be
fold elides.
It would be a nest list f command.
Yes, absolutely, and we should have that. I don't see any reason we don't have that. I mean, nest f comma 5 of x.
Correct.
That seems like a nice sensible thing to do.
Right, and then nest f comma 1 would be like paired.
I understand. A nest, I mean,
or we could even go one step further and have nest of 5 of f of x.
We haven't done that in other places.
Well, in celebration of the centenary of the combinator, we can just have all these functions start to combinator themselves. That seems kind of weird, and I would argue, I mean, okay, so in the case of paired, the generalization, yeah, right. So Seth on our live stream is suggesting what you also have here, which is that paired of hfx is that. So in other words, that paired of rule fx would turn into x arrow f of x, which I think is nice.
But then we lose the operator form, and paired should really be defined in terms of the operator form, and you don't really need the x in there.
So what? I mean, so yeah, that's right. But I mean, why do we lose the operator form? We have paired.
Well, if you have multiple arguments, then paired of f comma h should be the natural.
This happens in other functions. There are signatures that can be expressed in the operator form.
Do we really need the x inside? Shouldn't we focus on the operator form?
We're going combinator crazy. I mean, well,
I mean, in a functional language, you usually don't put the x next to the f. A paired of f is a function. Yeah, I mean, like our.
Well, you're saying like reversed. You're saying
yes. Why not? Yes.
Oh boy. You're saying, and you did define an operator form there, right? So you said paired of f of x. And then you're suggesting that paired of f comma rule or rule comma f.
It is true that I found this version more useful than the two args.
I mean, I can absolutely see mapping paired of f over things as being useful. Right? Like if I say pair, which is what we'd essentially done before there, paired of f slash at, or let's go full whatever, map paired of f of, this is, we're going functional crazy like that. That's kind of nice. That is nice. All right, let's implement paired like reversed. So represents a form of f in which it's paired with its argument.
Mm-hmm.
Now notice that that's only a one arg form, that's f, a monadic f, so to speak.
Mm-hmm. We could actually add your h in the second argument after f.
Why do you want it in the second argument, not the first argument?
It seems like these wrapping functions that we would use in other places like inner and distribute and other things that we put at the end.
Fair point.
You do it after you have mapped with f.
Yeah, fair point. All right, let's implement that. Okay, I like this. Okay, let's see whether very quickly we can go over these. Oh boy.
So yes, so I think this is a great idea. It's just that I don't think this is restricted to data set. This is an operation that could be performed on anything. And
what is the
design,
issue? This is how deep the mapping goes. This is a map.
Yes, this is mapping across different levels. It's just that the defining place is the leaves of an array.
I understand. So in a sense, if we had a named level, levels were designed a long time ago. And -1 is a purely structural definition. But if we had something that said map F dataset, let's say, I'm not suggesting this is necessarily right, something like that.
Right.
That's a little crazy.
My suggestion further down goes exactly in that direction, naming the levels.
And Genesis on our live stream is suggesting input-output as a name for paired. I think we want it to be more like paired because it's an operator form that apply like reversed. Sorry, what were you suggesting down here?
Yes, what I'm suggesting is to introduce something that is a naming of levels, like list level -1. So look only at the list levels and count -1.
I understand.
And this
well, you're saying, yeah, you're saying of a head. You're saying look only at the head list. Consider only the head list.
Right.
So we might be saying map fx, and then only the head list, level -1.
Right. I mean, lists are so important that they deserve their own structural functions. And so far, we only have array depth versus depth.
So what do you do for data set where it's either list or association?
Well, we would have to name it. This goes into a bit like allowed heads direction.
Yeah, but I mean, so what are we trying to achieve here? I mean, in other words, the blind version of this, where you're spraying the whole, I mean, what I would have thought we more want. Okay, what I'm trying to do is to make functions that operate on a data set that do not require inside the data set functional programming stuff. You know what I'm saying? So in other words, right now, we have some random data set. I don't know, let's pick we can make a data set from this, for example. Okay, so now if I say that, select even Q, for example, that's a bad, well, yes, fine. Select even Q, right? I'm going to get that. Okay, but the question is, how would I do that if I was not? Well, let me give I need a deeper example. But how would I do that? How would I do that select operating on the data set at a particular level? I mean, I've got a way to do it using these sub-value things, but is there an external function application way to do it? Chris, you're the expert. You should know.
I am not the expert on computations with data sets. Jose is.
I mean, data sets should behave like standard arrays from the structural point of view. So I would expect that map indicating a level does the same thing.
But it's truly obscure. I mean, because it's got to glue levels back together again and all kinds of things like this.
But I think the difficult point in Chris' request is that he doesn't want levels counted from above. He wants levels counted from below because he wants the leaves, no matter how deep they are, in the various places.
Yeah, I understand that point.
And that concept we don't have anywhere in the system for lists.
I understand. You're saying array depth is a way where it's looking at a depth, but only for array-like constructs.
Exactly.
But we don't have a level spec.
Right.
I mean, going down that number of levels, it's like, well, you can just count them and see how far down it goes. But going up is the complicated thing. I worry that it's just full of bugs. I mean, it's just like map at level -1 is very rarely useful because it's so structural and it ends up, wrapping itself around all kinds of weird things. We're not going to solve this problem right now. Let's just have a very quick look in the tiny amount of time that remains.
Only one more comment. I think that the new thing with dataset is that they are naturally rugged objects, while in the rest of the system we have the tendency to work with rectangular objects.
Right. Seth is pointing out that query lets one do exactly this thing, and he's right. Yeah, he's absolutely right. I just never use query. But Seth is writing a book about this, and he's going to tell us how to use all of this stuff. Yeah, I mean, honestly, that's completely correct. I mean, if I just said query of select even q of %345, I should get the right answer. Yes, I do. I just don't think in terms of query because we invented the subvalue syntax first. Yeah. I mean, I also think, right, query needs to come out of the shadows, which it hasn't for me yet.
So the last two topics are two minor geo-related things. This one we discussed some time ago, a way of getting from a geoposition array lists of geopositions. And the names we proposed were regions and points, but I don't really like them because they sound too geometry-like. And I wanted something more powerful and generalizable to geovectors, etc.
So what are you proposing?
Yeah, I was proposing this convention of saying I want a list of geopositions or a geoposition list. So there will be these 5 cases: list geoposition, geoposition list, then list placed in various places.
Yowie. And what function are you feeding this to?
It's a method for extraction from geoposition objects and geovector objects. And then it will be list, geovector, etc. Because the problem is that people get these arrays and they want to convert them into lists of individual geopositions.
I know, yeah.
And we don't have neither thread nor flatten work well enough.
Right. I mean, I would think factoring that concept, I don't like it very much. I don't like this. I do not like this. I do not like this. I don't like this. I mean, we could do something like this, where we're basically giving the head list, so to speak, list of geopositions, where you're giving the heads in the correct order. That's not totally silly. I mean, it's a lot. By the time we're saying list geoposition list, that's pretty weird.
Mm-hmm. This might work if we don't have any sort of threading of properties.
I see. Well, that's my first take, is that we can factor this by just naming the heads there.
Mm-hmm.
We should talk about how Flatten works. This seems like one that might be simple.
Yes, this was just to tell you that we changed the behavior of house signs, which I consider a bug of what we had before.
Well, you mean the clock has gone past before midnight type thing? What does it do?
Well, it's So the fact that before, in order to have a negative specification, we require the signs in the 3 places. Now it's only in the first one, which is what standard it's done usually. So that first.
Oh, I see. Oh, that's bonkers. I mean, if somebody gives that, you should convert it into this, but you should also allow just a single minus sign.
Exactly. So before we were returning what it's there in the first line, which wasn't correct.
That's bonkers. Yeah, I agree with you. You've got to document it carefully, but I agree with you.
Yes. So yes, and then one user had suggested the opposite direction, the fact that we can return from DMS3 signs. So I have added this plus minus in the same way that we had EW and NS to report signs. Then there is this plus minus, and then it will give a sign.
Okay. Oh, I see. To give the sign explicitly,
exactly.
Even if it's plus.
Exactly. Yeah. So the important thing was to have the minus rather than an east or west. Sorry, a west or south. I don't know what to do with the plus.
I see. You mean whether to give a plus or whether to suppress it?
Exactly. Yeah.
Well, we don't suppress east or west, so I mean, why not give the plus?
Exactly. Yeah, that's my argument.
What do they do for right ascension and things like that? Isn't that
That's handled through mixed quantity, mixed units, sorry.
But does right ascension have a plus and a minus?
Well, it returns quantities with numbers and their units. So yes, the numbers have their signs, and they follow the conventions that we have right now.
Well, this seems okay to me.
Mm-hmm. Okay.
All right, so we got to come back next time. We might need to talk about geoposition list, which doesn't sound quite right. And we need to come back next time and talk about dataset mapping functions. And let's implement these functional programming things and see how we go. And we're forking off another meeting specifically about combinators, and we can have a little. I'm about to start researching Moses Schoenfinkel in preparation for writing something about the centenary of combinators. And I have this bizarre theory about I have this bizarre historical theory, let's say, about Schoenfinkel that we'll see if it's true. Anyway, I mean, Schoenfinkel unfortunately ended his days in a very unfortunate way, but that's a different story. He was a student of Hilbert's originally, and but I don't know how much is. I mean, I tracked him down back when I was writing the NKS book because I wanted to have dates for him, and that was difficult to find. Okay, in any case, different topic. All right, well, very good. Oh, wait a minute. Carl is saying he'd like to flag that geoposition of multiple points is kind of weird, and it would be great to get better support for it. Well, that's what we're trying to do here, I think.
Sorry, what was the complaint?
That geoposition of multiple points is kind of weird. But I mean, yeah, we have pointed multiple points too. So I don't think it's any different. It's
important for packing to manipulate all of them at the same time.
Right. And I mean, notice, by the way, and I'd like to make this point, that, sorry, lots of points running around, that point of a list of coordinate pairs or triples, we don't have all this packing, unpacking, sub-value stuff for points, do we? Like nobody is asking for to a point. I mean, that is an interesting question. A point of a list of points, point of a list of coordinates. Shouldn't we be able to turn that into explicit, a list of points? And why has that never come up? And why does it come up with geoposition, but it doesn't come up for point?
I don't know.
Yeah, I think that's an interesting question, which might reveal that there's some other lack of some function related to geoposition. So let's.
a small difference, well, perhaps it's the important difference, is that point only support one level of list, while geoposition supports any level of list. So sometimes you have very deep objects and you want to convert them into one.
Let's discuss this another time.
Okay.
All right. Talk to you all soon. Thank you all. Thank you to people on live stream. See you all later.